All right, in this video, we are going to get started with a new functional group that has a nitrogen in it. There are two functional groups that have the nitrogen. They're amines and amides. An amine has this functional group. And amide has this functional group. Okay, so this is what an amine looks like. This is what an amide looks like. An amide has to have a carbonyl attached to the nitrogen. Let's back up a second. If you remember, nitrogen is in group 5A of the periodic table. It's got 5 valence electrons, and it normally has 3 bonds and 1 lone pair. Okay? If you have hydrogens on the 3 bonds, this is just ammonia. But if you replace a hydrogen with an alkyl group, it could be a methyl, ethyl, a 17 carbon alkyl group, anything. You just replace one of the hydrogens, you've created an amine. So this would be the shortest, smallest amine. A methyl group attached to a nitrogen, and the nitrogen has 2 hydrogens. Okay, we categorize amines as primary, secondary, and tertiary amines. I'm going to erase amides for now because we'll deal with them later. Primary amines have 2 hydrogens attached to the nitrogen, and then however many carbons, but basically what you need to know is that the 3 bonds of the nitrogen, 2 of them are connected to hydrogen, and the 3rd bond is connected to an alkyl group. So like I showed you earlier, this would be an example of a primary amine. You could have 2 carbons, you could have 10 carbons, you could have 100 carbons, all in this direction. But so long as this nitrogen has 2 hydrogens attached to it, that's a primary amine. A secondary amine, one of these 2 hydrogens is substituted with an alkyl group. So we call it a mono substituted. There you go. So let's take this hydrogen. I'm going to put a carbon here. And then this one, let's say I'll have 2 carbons. Okay, let me be consistent since I'm kind of condensing it. Let's just go ahead and do this. Okay, so this is an example of a secondary amine. The reason they call it mono-substituted is that, you know how we had an amine that had 2 hydrogens? Well, now that you take one of those hydrogens away and you replace it with an alkyl group, you're substituting one of the hydrogens with an alkyl group, so it's called mono-substituted. If you substitute both hydrogens with alkyl groups, you then have a di-substituted amino group. By the way, this over here, they call this an amino group. And an amine has an amino group in it. So an amine has an alkyl group attached to an amino group. A primary amine is an alkyl group attached to an amino group. A secondary amine has 2 alkyl groups attached to that original amino group. All right. Tertiary amine. Let's do that. Tertiary amine is di-substituted. And what does that mean? Remember, amines have 2 hydrogens always. But the minute you start primary amines, 2 hydrogens. The minute you take away one of the hydrogens and put an alkyl group, that makes it into a secondary amine. The minute you take away the other hydrogen and put in an alkyl group, that's a tertiary amine. So let me show you what a tertiary amine looks like. Here's the nitrogen. Let's say I put a methyl group here. Let's say another methyl group here. And let's say I have an ethyl group here. So this is a tertiary amine. It's di-substituted. Secondary amine is monosubstituted. Primary amine looks like this. Okay? You need to be able to recognize in a structure which one's a primary amine, which one's secondary, which one's tertiary. Sort of the way you did with the alcohols. You had to figure out if the structure had a primary alcohol, secondary alcohol, tertiary alcohol. Now you have to think of amines, but new terminology, because amines are named a little differently than the way the way we thought of the alcohols. All right. Let's do proper nomenclature of amines. So right now what I showed you was the different categories of amines. Let's first focus on the common names of amines. And these remind me of the way you name ethers. Remember the common name for ethers? You had an oxygen in the middle, and then you had alkyl groups on either side, and you would alphabetize them, and it would be ethyl, methyl, ether, or dimethyl ether, stuff like that. Common names for the amines are the same way. You have the nitrogen, and then you just name the alkyl groups around the nitrogen. I kind of wish I hadn't erased what I had earlier, because it would have been a nice example, but let me go ahead and do it over again. All right. First thing, recognize that this is a primary amine. Why? Because it has 2 hydrogens attached to the nitrogen. All right, let's do the common name. What is this alkyl group? 2-carbon alkyl group is ethyl. So this would be ethyl amine. Okay? Let's erase this name now. And let me put in this. Recognize that this is a secondary amine because I got rid of this hydrogen, put in another alkyl group. Now you just alphabetize them. E comes before M, so ethyl, methyl, amine. All right? Now that was a secondary amine. Let's go ahead and do a tertiary amine. Let's say I put in another methyl group. All right, so let's name this one. E still comes before M. These are 2 methyls, so you have to say dimethyl, but remember you don't ever alphabetize the di. So it's going to be ethyl dimethyl amine. Ethyl dimethyl amine. So that's common naming of amines. Let's now go into IUPAC naming of amines. IUPAC. All right. So with the IUPAC naming of amines, you need to get the longest parent chain that contains a carbon that has the nitrogen attached. So let's say I have something like this. And let's say I have a bromine over here. Okay? So I'm going to do the IUPAC naming. Normally when you have a big, long, complicated molecule, you don't even try to do common names. But for this one, we're just going to do the IUPAC name. Longest parent chain, and you want to number it so that the amine has the lowest possible number. The carbon that has the amine attached to it has the lowest possible number. So it looks like we're going to be numbering right to left. 1, 2, 3, 4, 5, 6, 7. All right, so if you do the alkane name, drop the E, and then throw in the word amine. So it's alkanamine. This would have been a heptane, but it's not a heptane, it's an amine, so you're going to drop the E and you call it heptanamine. Okay? And you're going to tell me where the amine group is. So this would be 3-heptanamine. Now, I see a substituent over here. Remember, the amine takes precedence over any substituent. So this would be 6-bromo-3-heptanamine. Okay? Now, let's make it a bit more complicated. What if you had a secondary amine? You have a methyl group over here. So you need to tell me that it's a heptanamine, that you have the amine group on carbon 3 of the parent, but you have to tell me that you have a methyl group. And where is that methyl group? You are now going to use the letter N instead of a number. So you will say N-methyl-3. Okay? So we're going to write 6-bromo-N-methyl-3-heptanamine. Okay, see what I just did, guys? N-methyl. This tells everybody that you have a methyl group attached to the N, not to the parent, to the N. You still have to tell me where the N is attached, and you still have to indicate the substituent. Okay, we'll do more of those in the next video.